Recording. So this is 8-2, and I don't like red. This is going to be called arithmetic sequences. And you've seen arithmetic sequences before. They're just, an arithmetic sequence is a sequence, it's a sequence that goes up or down. Sequence that, which or that? I never know. Goes up or down by a constant. So the one we just saw, 25, 20, 15, 10, that's an arithmetic sequence. And if you graph arithmetic sequences, what shape do they make? A line, right? And so they're linear, basically linear equations where the input is just integers. So it's just dots, right? If you were to graph it rather it's a discrete set of numbers, meaning it's not defined at every point on the interval, just at the dots, okay? And so recursively, you could define it as a sub n is equal to a sub n minus 1, a sub n minus 1 plus d, or similarly, a sub n minus a sub n minus 1 equals d. So this just means to find a term, I can take the previous term and add a common difference to it, and I could get it, or I can subtract the higher term minus the term below it and find that common difference. And that's basically how you do it. So you'll just see some easy problems like find the common difference. Find the common difference, and for this arithmetic sequence, 5, 8, 11, 14. What's the common difference?
3.
D equals 3. Is that hard? Just subtract the higher term minus the lower term. You can go down, okay? So to find the formula, I'm going to go through kind of a little derivation of the formula because it's I won't do the one for the sum, but I'll do it for this one. Finding the, so this is a recursive definition, finding the a sub, or finding the nth term. The way they do it is like this. They say a sub 1 equals a sub 1. A sub 1 equals a sub 1. Right? A sub 2 is equal to a sub 1 plus the common difference. Right? A sub 3 is going to be equal to a sub 2. Yes? A sub 2 plus the common difference as well, which can be rewritten since a sub 2 is equal to a sub 1 plus d. I could write a sub 3 as a sub 1 plus d plus d. You guys understand what I did? I substituted this into here. Do you have to know how to derive this? No, but I'm just trying to show you where it comes from. Okay? So then, since I know a sub 3, which I can rewrite a sub 3 is equal to a sub 1 plus 2d, right? And so then, and so a sub 4, what would a sub 4 be? A sub 4 would be a sub 1 plus 3d, okay? So using that idea to find the difference between, or to find the next term, right? How do they do it? A sub 1 plus 3d. So can you kind of see that a sub n would be equal to a sub 1, since to find a sub 3, I take a sub 1 and then I add 2 d's to it, right? To find a sub 4, I take a sub 1 and I add 3 d's to it. So to find a sub anything, I take 1 less than whatever the term is, so n minus 1 times d. So this is, do you kind of see that pattern there? So to find the nth term, all I have to do is take the first term, take 1 less than the term that I'm looking for, and multiply it by the common difference. So for example, in this one right here, this is the 4th term, right? If I wanted the 4th term of that sequence, a sub 4, it would be equal to a sub 1, which is 5, plus 4 minus 1, which is 3, times the common difference, which was 3, and I get 14. So, get it? So that's an explicit formula for finding the nth term of a arithmetic sequence. Find the nth term of the common difference. So another example. So using this formula, find the nth term and common difference if oh no, sorry, that's the wrong example. Find the nth term with common difference 5 and first term 9. Oh, you don't even have, it's just plugging into the first term equals 9. So all you have to do is go a sub n. What goes next? What goes here? 9 plus n minus 1 times 5. Okay? So there's a formula for finding the nth term if the first term is 9 and the common difference is 5. Easy enough? Okay. It does get slightly complicated. Like sometimes I'll give you stuff like this. Find the nth term of an arithmetic sequence if the 5th term is 19, 5th term equals 19, and the 9th term is 27. Okay? So this one, really what you're doing, you're setting up 2 equations with 2 unknowns, and then you have to solve them. All right? So what you want to do is a sub 5 is equal to, oh, we don't know what a sub 5 is, but we do know, yes we do, that the a sub 5 is 19, right? But that's got to be equal to a sub 1, which we don't know, plus n minus 1 times d. Yes? No?
5 minus 1.
5 minus 1. Okay? With right there. Okay? And then I know for a sub 9, that looks like a 9 sub 9. That's a 9. That's an 8. Okay? Equals 27. And a sub 1 is still going to be the same number. But when I plug in 9 into n minus 1, right, I get out plus 8d. And then now I have a system of equations. So see this system right here? 19 equals this. How could I solve this system of equations? Add them or subtract. I'm going to just make this one negative and add them. Okay? So when I do that, if I were to make these all negative, right? Negative, negative, negative. I could do that and add them together. I get 8 equals the a's go away, 4d. So d equals 2, right? And then I just take that and I plug it into either formula, and I solve for a sub 1. Okay, so let's plug into that second formula. 27 equals a sub 1 plus 8 times 2, and I get a sub 1 equals 27 minus 9. What's that? 27 minus
16.
6.
No, 27 minus 16.
27 minus 16 is 11, right? And so now I have my formula, which I could rewrite for finding the nth term. A sub n is equal to 11 plus n minus 1 times d, which is 2. Well, what I just did, so basically I solved this system of equation. And so I have to plug in, so this is basically the y value, this is like the x value, or the independent, dependent, and then you solve for d, and then you plug back in and solve for x.
Can we leave it like that, or would you want us to just change
Either way, okay? Yeah, if you could simplify it and rewrite this as a sub n, but this kind of shows more, I think it's more, because this tells you the first term, and you're plugging in the nth term. You could simplify it, and it's minus 2, would that be 9 plus 2n, right? Same thing, okay? Either way, it's okay. Questions? All right. So in the book, they go through this thing. They go through the derivation of this formula, but I'm not going to do it. It involves a process called, which we taught last year, called mathematical induction, but we're not going to do it right now. But the sum S sub n for an arithmetic sequence is equal to n times a sub 1 plus a sub n divided by 2. Okay? So this is the sum of an arithmetic sequence. And the way they develop this is they write out, okay, a sub 1 plus a sub 2 plus a sub 3 plus dot, 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 until you get to a sub n. And then they substitute one thing in for the other thing, and it ends up simplifying to this sum using a process called mathematical induction. If you're interested, there's a derivation of the formula in the book. But this is how you find the sum of an arithmetic sequence. And I forget who it was. I think it was Descartes. I forget who the person was. But the teacher said, add up all the numbers from 1 to 100. Okay? And he goes, I got the answer. It's 50-50. And the guy goes, what? How'd you do that so fast? And he figured out the formula. And then, so if I want to find out the sum of all the numbers from 1 to 100, okay, the first number is 1. The last number is 100. And then how many numbers are there from 1 to 100? There's 100, so I would multiply by 100, and then I divide by 2, which would give me 50 times 101, which is 50-50. See, that's if you add up 1 to 100, that's what you get. I bet you could try it along with it. But I forget, was it Descartes? I forget who it was. Maybe it was, I forget. One of those famous math dude guys. Or maybe it was Mr. Leader, but it wasn't. Anyway. So then you'll have things like find the partial sum, or they'll use summation notation on you, and they'll say, find the sum from n equals 1 to 20 of 7n plus 1. And all you have to do is find the first term. What's the first term? You plug in 1 in here and you get out 8. What's a sub n? In this case, n is 20, right? So the last term is, if I plugged in 20 in there, what did I get? 141. And then I just plug into this formula, okay? So I'd go n, how many terms from 1 to 20? 20 times 8 plus 141 divided by 2. And I get 1,490. Isn't that nice and quick? You don't even have to plug it into your calculator. You could just use that summation formula. Easy enough? Now, sometimes they'll just give, can I go on, or are you still writing?
So we'll end all
Let me
these
pause.
number.
Let me pause for station. We're moving on. By the big pop. So you guys never heard that joke before.
No.
Like, find the 15th partial sum. Find the, isn't this stuff nice and easy? Just wait till you take calculus next year. You'll be a lot more stressed out next year. Partial sum of 2, 5, 2, 5, 8, 11, dot, 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 dot. Okay? And so if you saw one like this, first thing you'd have to do is you have to figure out what the nth term is, but that's pretty easy. What's a sub n equal to? What's the first term?
2.
2. What's the common difference?
3.
N minus 1 times 3. Okay? So all you have to do is take a sub 1 plus a sub 15. Multiply that by 15. This is what this means. And divide by 2. Okay? So once you know the formula, you can figure out that a sub 1 is, we already know a sub 1, right? So a sub 1 is 2. A sub 15 is 2 plus 15 minus 1, which is 14 times 3, which is 42, plus 2 is 44. And then you can take that and divide that by 2, and you get that that would be equal to 345.
Yeah.
Isn't that cool? Isn't that cool? Okay? So you can find the sum of any sequence. Then, there's some application problems, which are kind of fun. So let me see if I can find that application problem. We don't have to do both of them because they're both kind of the same. Uh-oh, where'd my application problem go? There it is, okay? So let's look at this one. So each row of an auditorium has 2 more seats than the preceding row. Find the seating capacity of the auditorium if the first row has 30 seats and there are 40 rows. So the first thing you have to do is find out how to find the nth term. So what do I start with? What's the formula? So you start, you have 30 seats, right, going across, and then you have 2 more seats, right, and 2 more seats, and so on and so forth. So you want to find out how many seats there are altogether, right? So the first row has 30 seats plus n minus 1 times what?
2.
2, right? And then, so if there's 40 rows, you start with, so the sum of the 40 rows is equal to the first row, which is 30. Whoops, I forgot to multiply by the number of rows, which is 40. Okay, times the first row, which is 30, plus the, what row would that be? 40, the 40th row, 39 times 2, 78, plus 30 is 108, divided by 2. Isn't that easy? And then I know that 40 divided by 2 is 20, and 2 times 138, what's 2 times 138? 2, 7, 6. I gotta look at my sheet. 276, and then add a 0 on the end for the 40. So there's 40 rows altogether. 2,000, or there's 2,760 seats. Easy?
Yeah.
Follow that? I like this other problem better, okay? Because it's a little more involved and it's kind of fun. So let's just, let's do this one. What the heck, we got that. So suppose you put $100 under your mattress. Let's get rid of this thing. Can I move you? Go away. Go away. Don't turn it off. Okay. Go away. Go over here. Go over here. So suppose you put $100 under your mattress at the end of the month. You continue to put money under your mattress each month and increase the amount by $5 each time. How much money is under your mattress after 1 year? Okay? So in this case, you kind of have to figure out the formula, not too hard. A spend is equal to 100 plus n minus 1 times 5, right? So in a year, you do this how many times? 12 times, okay? So S sub 12 is equal to 100.
Wait, wouldn't it be 12?
Sorry, I always forget that first one. 12 times 100 plus, on the 12th month it'd be 11, right? 12 minus 1 is 11 times 555. So on the 12th month you're putting $155 in your mattress, and you're dividing that by 2. So you get 6 times 255, right? Which is, put in, how much?
0.
3? 0?
Wait, no, I'm doing it.
Oh, you're doing it in your head. 6 times 250 would be
1,530.
$1,530. See? But you shouldn't put money under your mattress anyway, because that's where the thieves always come to look. And anyway, you earn better interest if you put it in the bank. Yeah. I once dated this banker. Did I tell you about that? Well, we broke up after a while because I lost interest. Okay. Sam's shaking his head. He hates my joke. Come on, audience. That's your homework right there. You can write it down. And that's the end of my video.